Today, let us explore the captivating yet concerning world of AI and its energy consumption. Artificial intelligence, or AI, has grown exponentially in recent years. It is revolutionizing industries and driving innovation, from voice assistants to autonomous vehicles. This rapid advancement, while coming with a significant hidden cost in energy consumption, also holds immense potential for positive change. To understand this, let us start with the basics. Training AI models, intense learning models, requires enormous computational power. These models learn from vast amounts of data through complex mathematical computations, which demand substantial energy. A study from the University of Massachusetts Amherst found that training a single AI model, like the Transformer, can emit over 626,000 pounds of CO2 equivalent, roughly the same as the carbon footprint of 5 cars over their lifetimes. The computational power for these tasks often relies on specialized hardware known as XPUs, which include GPUs, graphics processing units, TPUs, Tensor processing units, and other advanced processors designed for parallel processing. GPUs, for instance, are highly efficient at handling the large-scale matrix operations required for AI but consume significant amounts of power. A single high-performance GPU can consume around 300 watts, and large-scale AI training can require thousands of these units to run continuously for days or weeks. Imagine the energy required to train one model and multiply that by the thousands of models taught worldwide. This energy consumption primarily takes place in data centers. These facilities, filled with powerful servers, are the backbone of AI operations. Data centers account for about 1% of global electricity usage, with AI contributing a growing share of this demand. In 2020 alone, data centers consumed about 200 terawatt-hours of electricity, comparable to the annual energy consumption of some small countries. AI's energy demand doesn't stop at training, it also extends to inference. Once trained, models must process new data in real time or near real time, which also requires significant computational power. For instance, running inference tasks for applications like natural language processing or computer vision can consume substantial energy, especially as the models become more complex and deployed at scale. This rise in energy consumption has significant environmental implications. The electricity used by data centers often comes from non-renewable sources, leading to increased carbon emissions. According to a report by OpenAI, the computational power used in large-scale AI training runs has doubled approximately every 3.4 months since 2012. This exponential growth is alarming, considering that the carbon footprint of training a large AI model can be comparable to that of a transcontinental flight. So, what can we do about this? The tech industry is already taking significant steps towards more sustainable AI practices. Researchers are developing energy-efficient AI algorithms that require less computational power without compromising performance. For instance, Google has developed AI chips known as Tensor processing units, TPUs, which are designed to be more energy efficient than traditional GPUs. This industry-led innovation gives us hope for a more sustainable future. Additionally, there's a growing emphasis on using renewable energy sources to power data centers. Companies like Amazon, Google, and Microsoft invest heavily in solar, wind, and hydroelectric power to reduce their carbon footprint. Google, for instance, has committed to running all its data centers on carbon-free energy by 2030. Moreover, advancements such as AI model optimization and federated learning are currently being investigated. These approaches aim to minimize the energy required for training and inference by optimizing the use of resources and distributing the computational load. For example, federated learning allows AI models to be trained across multiple decentralized devices, reducing the need for central data processing and thus saving energy. In conclusion, while AI continues to revolutionize our world, it's crucial to consider its energy impact. Balancing AI advancements with energy efficiency is a technological challenge and an environmental imperative. By prioritizing sustainable practices and leveraging renewable energy sources, we can ensure that the benefits of AI are realized without compromising our planet.